first, thanks to the organizers for inviting me. I'm Jonathan, and so I'm going to be talking about something called the slow internet, and I'm also going to be demoing the slow internet. So I'm talking about 3 pieces of software that I wrote in Racket. This is Molasses, my slow internet client, and it's connected to Gopher 21, which is my slow internet, or it's really a Gopher server that's running on this laptop. And I'm also going to talk about Hashlang Magic, just because I use it in both of those, and people might find that interesting. So I'll explain what the slow internet is in a minute, but first a little bit about me. I'm a C programmer for about 25 years, and most of my work is in lower level stuff like embedded systems and Linux and things like that. I've always been interested in Lisp, and so that's how I found Racket. And when it comes to Racket, I'm definitely a hobbyist, and I'm definitely not an expert. So the slow internet, there's a number of kind of loosely related philosophies and ideas that kind of fall under the umbrella of what I'm calling the slow internet. But I like the term slow internet because the analog it has to the slow food movement. If you're not familiar with that, the slow food movement was kind of a response to fast food and the commercialization of the food system. So really you could think of the slow internet as essentially that idea, but applied to the modern internet, social media, and things like that. So slow internet is less commercial and less centralized, and it's essentially a lot more personal and person-driven instead of algorithm-driven, which really, the way I think of it is the way the internet was when I started using the internet in the mid-90s. But, so key protocol for me in the slow internet is Gopher. I don't know how many people have ever heard of Gopher here. Plenty of people my age and older probably have. But it was invented in 1991. It is defined in RFC. As you can see, this is Gopher. You're looking at it. As you can tell, it's primarily text-based, and it's a menu-driven system. And it kind of presents a hierarchical structure, roughly. And the protocol itself is stateless, and it's extremely simple. There aren't any headers or anything like that. So a Gopher request is essentially a string followed by character term line feed, and that's it. And that string is called the selector, and the selector generally refers to a file name, or basically, usually it's a path name on the host system or on the server, but technically it could be anything. It's up to the server to interpret the selector and respond. So really, all the server does is it receives selector strings and responds with either a file or a directory listing. So this is kind of an example. This is kind of the raw directory listing format. A lot of the Gopher spec is basically defining this syntax. So at the bottom, you have a tabular representation for easy reading, but the top is the basic, the raw directory listing. So every line in the directory listing is a menu item, and the first character is the item type. And in this case, the first 5 lines start with I, which just means it's an informational line. So it's not supposed to be a menu item, it's just informational text that the client will display. And following that, there are 4 fields that just separated by tabs: the display string, the selector, that host, and the port. So the item type is very important because that's the only way that the client actually knows how to interpret the data it's going to receive. So the spec defines a number of different item types. Some of these are outdated. The most common one is 0 for a text file or 1 for a directory listing. There's a couple interesting ones in here. 7 is a search server, so I'll talk a little bit more about that later. And so there's G for GIFs and I for every other image type. So it's up to the client to figure out what to do with that. And so in modern Gopher, there's some conventions that people use. So lowercase h for HTML and S for sound file, and there are others, but those aren't technically part of the spec. And there's another, just one, item type 9 is a binary file, which, generally, there's not much you can do other than download it. I also want to briefly mention Gemini, which is another protocol. It's a modern protocol, and it's designed to be somewhere in between Gopher and HTTP. It's still basically text-based, but it has its own kind of lightweight markup language called gemtext, but I'm not going to go into a lot of detail on Gemini. So Gopher 21 is my Gopher server, is basically the first significant Racket project I wrote. I started with the web server tutorial example on the official Racket documentation. And so Gopher 21 really just does, all it mostly has to do is respond to selectors with files or directories. And so in the case that a selector refers to a directory path, there's two ways it can build the directory listing. And one is there's a standard called a Gopher map, which is kind of like index.html of Gopher. And so if a directory has a Gopher map in it, then it serves that as the directory listing. And so the Gopher map is pretty slightly simplified version of like the raw directory listing format. If there's not a Gopher map in a directory, then it will dynamically build the list and send it to the client. So I wanted to demo the search index feature. I'm going to skim over the details here, but basically you can pre-process a set of text files to build a file called I call it corpus, and that enables you to like rapidly do keyword searches over the corpus. And I'm not going to go into the details, but I have on here, I've got probably about a 500 megabyte subset of Project Gutenberg, and I will show you the search. So the search item type is the only item type where the client requests the user for a string to add to the selector to use as the query string. So it's really the only built-in method to get user input and send to the server. So I search for Mark Twain. I found 176 files that matched, and these are the number of references in the file. So this first example is an autobiography of Mark Twain. And then you can also do quoted search. And this basically, on the server side, is doing the same keyword search, and then it's doing the string search through that to find exact matches for the text to Mark Twain. So now you can see we only have 43 files that hit. And so the response to the search request is just another directory listing showing all the hits. And that's really all there is to say about Gopher 21. The servers are fairly simple. So Molasses, my goal with Molasses was to create a graphical Gopher client that had multiple tabs, but also has like the features that you'd kind of expect to find in a web browser, like history and bookmarks and things like that. It supports Gopher, Gemini, and I added HTTP just because I could, because Racket provides that and it's pretty simple, but I haven't actually used that a whole lot. And I also wanted to have easy keyboard navigation that the terminal Gopher clients have. And the big thing though is, as the project grew, I decided I wanted to be able to render HTML, so that's mostly what I'm going to be talking about. But there's a couple features that Racket has that are important to me for this project because, as you can expect, there are not a lot of Gopher users who also use Racket. So if I was going to distribute a niche within a niche, so if I was going to distribute binaries, I had to be able to do it in a way that people can use it.
Are you the only one?
Maybe.
Yeah, I've never reviewed it.
There's probably someone else. You might build. There are actually a fair number of Scheme and Lisp people in Gopher space, as it's called. I don't know if I've ever seen anything specifically talk about Racket. And I use the Racket cross compiler on my Linux desktop to build binaries for a variety of different platforms. So that's helpful. I'm using a couple different packages, in addition to the standard GUI stuff, I'm using HTML parsing, which the author Neil made some improvements at my request because I'm running into some older HTML that probably most people haven't tested with. And that converts to SXML, and so I use SXML to do the parsing or processing of the actual HTML. So when I originally wrote Molasses, I was using the editor framework, which if you're not familiar with, there's a editor canvas and a text editor. And so that was working great that works for Gopher, it works for Gemini, even works for simple HTML. But unfortunately, the text editor does not support the ability to flow text around images. So I wanted to have that for better HTML rendering. So I needed to come up with a solution, and I was pretty reluctant to actually discard the editor framework, but I spent quite a bit of time trying to think of ways to do it, and I decided there wouldn't be an easy way to do that without actually modifying the Racket internals. So what I ended up doing was creating my own canvas that I just extended the base canvas class that Racket provides. So this new layout canvas, it kind of combines functionality that previously existed in the editor and editor canvas. I simplified things a lot by only allowing one operation to add an element to the canvas. So you can append elements, but you can't insert them, you can't delete them. Other than you can delete all of them at once, but you can't delete individual elements. But the elements within the canvas can be snips or strings. And so I'm doing pre-CSS. I don't handle CSS at all. So back in those days, tables were used a lot to do layout. So tables are something I was going to need to add as well. And I'm matching the rendering and layout style in Netscape Navigator 4 because that's just what I care about. I don't care about newer stuff. So Canvas has to do a lot of things. I'm not going to go into a whole lot of detail here either, but probably the trickiest stuff were concurrency issues. I borrowed an idea from the editor framework where it has like a start and end editor sequence functions that you can bookend any modifications to the canvas contents. So I use that to prevent the canvas from trying to draw something while I'm modifying it. But even things like, just highlighting text, I had to do that myself. Which actually was a lot more annoying than you would think it might be. So here's a simple kind of class diagram. I have layout canvas extends canvas, and my browser canvas extends that. And browser canvas is where I keep like the application-specific stuff, like all the stuff related to Gopher and Gemini and HTML and HTTP. But the browser canvas can contain snips and strings, and one of those snips is table snip, which in turn has cells, and a cell is essentially a stripped-down layout canvas. It can hold all the different types of snips, and it handles all the layout that the canvas does. So cells can also have snips and strings, and it kind of shares a lot of the layout algorithm in a separate module, but unfortunately there is still quite a bit of duplicate code between the cell and the layout canvas. Snips were a very clean way to add functionality. So there's already an image snip, so I had image support already. But HTML images add some things to that. There's attributes like increasing the white space around an image or resizing it. So I did extended image snip to create HTML image snip. And there's also image maps in HTML, which if you're not familiar with, that's where an image has regions that are links. So I extend that as well. I extended my HTML image snip to create a new snip and on the image maps. And HTML links themselves are a mix-in so that I can apply that to any other snip. And that does things like if you hover the mouse over a link, it'll change the mouse cursor or update the status bar with the destination of the link. I'm not going to go into a lot of details on tables. They're defined in RFC. I have a pretty complete, it's not none of this is like 100% complete, like HTML 3.2 compliance or anything. I have a relatively complete table implementation, but yeah. The hardest part probably is like the auto layout algorithm to determine like the widths of cells, and the RFCs has suggestions in some places and not direct. So some of it is up to the implementer, but I basically did the best. So now I'm going to do a demo. This particular web page doesn't render great in like the larger font size. So this is the layout canvas, and this is a website I spent a lot of time on in college in the 90s. Probably just pages of reverse engineering, and this to me is just a classic of this era of web design. You can see this is a table, like all of this is tables basically. But if we scroll down, there's an image. This is an image map. So like this red door is a link. The Raven's a link. The Boulder's a link. This is a link. I mean, there's probably like 10 links in there. Image maps are annoying because you can define them as circles or polygons or all kinds of different ways. So here's another page just to show more tables. So this is basically my test case, and if something didn't work in here, I try to fix it. And other than that, I don't care. You shouldn't. Mostly because I host this on my Gopher site. But if anyone else ever used it and wanted me to fix something, I'd probably look into it. Okay, and so the final thing is hashlink magic. The file command in Unix is probably more interesting than you thought it was. So this is an implementation of the DSL that it uses to determine what type of file something is. And there's thousands of these tests have been written. And it basically, each magic file defines a series of tests. I'm going to go through this pretty quickly, but my version also is like not complete, but it supports a good portion of what file does. And essentially, every magic module will compile into two functions, magic query and magic query all. Magic query just runs queries until one succeeds and then it stops. Magic query all will run all the queries in the file and return a list of results. So I'm also not going to go into a lot of detail in the syntax, but every line in a magic file is a test with 3 or 4 fields. So you have the offset of where to read from in the file, the type of data to read, the value or operation to compare the data against, and optionally a message that is appended to the output. So like file will do a lot more than tell you what type of file something is. It can pull out any kind of metadata you write a test for. Queries are nested, so if the top level test succeeds, there's descending tests beneath that, so it's basically like a set of if-else-if nested tests. At the bottom here, this is just to get an idea what it looks like. So this is just a very simple one to determine if executable is like a DOS executable or Windows executable. So I should mention that magic is useful for Gopher because, Gopher, as I explained, that the file types are pretty limited options that you have. So like for that image type, like what type of image is it? Server doesn't know what the client supports. So it's up to the client to kind of figure out what type of image that is. So I use magic and Gopher 21 and Molasses. So here's an example of how I use a magic file that I use in Molasses. This is reading an image to tell when I'm loading it in HTML and determining the type. So go over this very quickly, but like this first query is actually a function definition, and it's a recursive function because it calls itself. And then there's another function definition for a function called PNG alpha. But the first actual query is this one, which basically the file starts with this byte string, then we know it's a PNG, and then we will call the use PNG alpha function on the file starting at offset 16. and then it will go through and check that PNG to see if it has alpha channel or if it has transparency, like a transparent color. And if it does, then it will append /alpha to the text, so the output will either be PNG or PNG/alpha. And then we basically do the same thing with GIF. There's a function for that. And then JPEG and bitmaps are simple because they don't support alpha channels. And in this case, we're expecting the data to be an image, so we don't have to do anything else to it. So this is kind of how I would use that within Racket. So first, we bring in the function. We rename the magic query function to image kind query. And then when we load the bitmap, basically the bitmap, when you load a bitmap, it has a kind argument, which is the type of image data that it's reading in and whether to create a bitmap with an alpha channel or not. So basically, we just use that magic to run on the data, and it outputs a string which is converted to symbol, which we use to create for that kind argument to the bitmap. But I think that's everything. Yep.
All right, we've got a little time for questions. This is so cool. I love that that fortress page. That was cool. I was wondering, so you're using snips for this, and something cool about Dr. Racket, you may or may not know, is you can embed snips directly into Dr. Racket. And I think it'd be really fun to be making slow internet web requests and then use the results of the request to write in a program right away. Have you tried embedding any of your browser components into Dr. Racket?
No.
Does that interest you?
I don't know. So the overall layout canvas is not a snip.
Yeah.
There's a lot of snips within it. And I would say the layout canvas code itself is kind of like a first draft of something that somebody could use somewhere else. But it's not, it's somewhat, I think it'd be it would take some work to actually get that canvas to the point where, although the cell itself, which is kind of a stripped down layout canvas, that might be easier to turn into a snip. It's not actually a snip either, it's just within a table snip.
Yeah.
But you might can do something with that, yeah.
Cool. Thanks.
Sort of along similar lines, the layout work is really impressive. I wonder, way back when, Netscape and later Mozilla, in addition to the navigator, had an editor that gave you a lightweight little WYSIWYG thing that mapped, unlike other WYSIWYG HTML editors, very cleanly onto the actual text. Is that something you have thought about, bringing this back to editing?
That would be a lot more work because, like I said, I dodged a lot of complexity by just making this a thing you can add things to in a list and just leaving it like that. Like if you go look at the editor code, like for text and things like that, which I did, and that was one of the things that convinced me I didn't want to change it. So yeah, there's a lot of complexity in there that I didn't need, so yeah.
Thanks.
Yep.
This is maybe less of a question and more of a request. I have often found the editor and snip APIs to be complex. You seem to have figured them out at least enough to write your own canvas and populate it with snips. If you write a book about it and put it on Gopher, I will read it.
Well, I should take this opportunity to say I don't know if I'm 100% using snips correctly because they're supposed to have an administrator. Mine don't. I just started using them.
They're free.
Yeah, I'm just using them, and everything seems to work so far. So it works.
Other questions? So I know a repository of things from the old internet is now on, I think, NeoCities or RioCities.
Yep. Okay.
Did have you taken a look around just to see what things of that vintage you're happy with or not? And actually, I don't know if that's too newfangled for you to want to deal with or not.
I think I've looked at some of those. I can't remember which ones, but I see things like that every once in a while. But I probably, since I do have HTTP support a little bit, I probably could try to point Molasses at one of those. As long as they're not using JavaScript or CSS, it'll mostly work.
I mean, I'm sure it's got a GIF of the guy doing the shovel feat. So that seems like it's got to be of the right vintage.
So like this is, it's real loud. This is a web page. This is HTTP. And this is one that was written, this is a textfiles.com thing. But this was written so that it would work without CSS or JavaScript, even though it has those things. So you can kind of render, that's a good idea. I should try that. I think I might do that when I get home.
All right. Well, let's thank our speaker.